Good evening, everyone. Welcome to week 9 of the tutorial lecture on social networks. So this week we'll be discussing assignments from week 9 of previous iteration of this course. So if you have any doubts, you can ask me in between or at the end of the session as well. So let us get started. Coming to the first question, in a random graph with 500 nodes and edges between any two nodes with a probability of 0.27, where can one expect the peak of the degree distribution graph? So basically degree is number of neighbors. So you have a graph with 500 nodes and edges are added between two nodes with probability 0.27. So you have a graph with 500 nodes and edges are added with probability 0.27. So this is known as the Erdos-Renyi model. And in such a model, peak of the distribution is basically probability with which the edge is added and max degree minus min degree. So probability is 0.27 and max degree is 499. So a node can be at most connected to 499 other nodes. Suppose we discard self loops as well, and minimum degree is 0, that is not connected to anyone. So this can be roughly approximated as 0.27 into 500, so which is around 135. If you multiply, you get 135. So the right answer for this question is option C. 135 is where you can see the peak of the degree distribution graph. Coming to the second question, in a random graph with 500 nodes again, if A, B, and C are number of nodes with degree 0, 300, and 600 respectively, what is the relationship between A, B, and C? So, okay, so let us plot a random. So in the Erdos-Renyi model, again we consider Erdos-Renyi model, the degree distribution is basically a normal distribution. So it looks something like where it is degree and percentage of nodes with that corresponding degree. So it appears something like this. So like a bell-shaped curve. So they are saying that A, B, and C in a node in a random graph with 500 nodes with degree 0, 300, and 600 respectively. So if you look first, let us locate where A, B, and C will lie. So A, B, and C. So A is uh, around. Uh, so in a random graph with 500 nodes, so maximum number of degree that you can obtain is around 499. So let's say this is 500 and this is 0. So where does C lies? So C is the number of nodes with degree 600. So 600 is basically somewhere here. Uh, Let me write. So 600 is somewhere here, maybe 600. So this value is C. 0 is uh, A is the number of nodes with uh, 0. So this is A, and B is the number of nodes with degree 300. So 300 is somewhere in between. So maybe somewhere here, and you get B over here. So from this graph, you can see that uh, is okay, okay. So from this graph, you can see that the relationship is, so B is greater than A greater than C. So this is the right relationship that should be obtained. But here the options, the four options that were given, so they have missed out on this option. So the right answer for this question should have been somewhat like this. So C less than A less than B. So this is the correct option for this question. 600 lies outside the distribution, and hence it is lower than 0. Therefore, C should be less than A, and B obviously lies between the two extremes. So B is greater than both A and C. So that's why B is the greatest, but A should be greater than C. So this is the correct answer for this question. Coming to the next question. Amit tosses 6 dice and stores the sum of the numbers he gets. If he plots the sum of the numbers on the x-axis and frequency on y-axis, what is the, in what range is the peak of the given distribution expected to be? So when you sum numbers from different distributions, the resultant is a normal distribution. This is the central limit theorem. So when you toss 6 dice, toss 6 dice, minimum you get is 1 plus 1 plus 1 plus 1 plus 1 plus 1, which is 6. And maximum that you get is 6 plus 6 plus 6 plus 6 plus 6 plus 6, that is 36. So the distribution of the sums would look something like this. Sum mean 1 and 36. The distribution would look something like this. So the peak is somewhere in between. So peak, so they are asking is what range is the peak in? So the peak would be 36 minus 1 by 2. 1 plus 36. So that would be 1 minus 1 plus uh, 35 by 2. That would be around 18.5. So in this four options, option B uh, correctly expresses the range. So it's between 18 to 24. So it should be around 18.25 for a large number of distributors. For if experiment repeated large number of times. Otherwise, it would be in the range 18 to 24. Is there any doubt so far in the questions discussed? Okay, so let us proceed to the next question. Coming to the fourth question, the power law states that the frequency plotted along the y-axis is inversely proportional to k to the power a, where k is the values plotted along the x-axis. So where a is preferably between. So let us look at the graph of the power distribution. So the graph looks somewhat like this. This is k, and this is, let's say, uh, the frequency f. So this graph is k to the power a. Now they have where a is preferably between. So the question here is incomplete. So preferably in between for World Wide Web, www network. So for the worldwide network, so a is between uh, 2 and 3. So a basically it's like this. So 3. So this range is only for www network and might vary for other types of network. So the right answer is option D. So this is the power law, and you see such type of graphs in preferential attachment network. All right, moving on to the next question. So you have question 5. In the given graph, a node X is introduced. What is the probability of a node of a new node being attracted to either A, B, or D, given that X makes only new friend? So in such questions, what we follow is the Barabasi-Albert model, which says a new node follows a preferential attachment, which means that new node uh, attaches itself to nodes with attaches itself with nodes having higher degree with greater probability. So if there is a new node X that is introduced, and you have, let's say, node existing nodes small a and small b. So let's say degree of a is less than degree of b, then probability of attaching to a is less than probability of attaching to b. So this is the Barabasi-Albert model. So in such questions, we'll follow this model. So now if we introduce a node X in this, and it says that what is the probability of a node X? Okay, so a new node X is introduced, and given that X makes only one new friend, what is the probability of a new node being attracted to either A, B, or D? So now let us look at the graph, and first let us write down its degree. So first of all, degree of A is 3, B is 2, uh, B is 2, and C is 3, E is 3, H is 4, I is 4, J is 3, G is 3, F is 2, D is 3. Now, given that, now then let us count the total number of degree. Total degree is twice the number of edges, which is twice into 15. So if you count, there are 15 edges in the graph, which is, so total degree is 30. So probability of attaching to A, let's say P A subscript A, will be 3 out of 30. Probability of attaching to B will be 2 out of 30. And probability of attaching to D will be uh, again 3 out of 30. So given that X makes only new friend, to which one it is attached? So of um, probability of attaching to A or B or D would be equal to PA plus PB plus PD, which is 3 plus 2 plus 3 over 30. That would be 8 over 30. So the right answer for this question is option A, 8 over 30.
Sir?
Yeah, go ahead.
Yeah, sir, I want to ask about the Barabasi-Albert model.
Yeah.
Uh, you have wrote here degree of a, small b, less than degree of a, less than degree of b.
So this is
As
for,
as I think we can do this question directly. Union of a probability of joining of x to a, b, and d. A,
yeah,
yeah.
so the,
This type of question we have been done already in our assignment.
yeah, yeah. So this is the same thing. So if you take the union, you get PA plus PB plus PD, and you have to
Yeah,
subtract the intersection part. But that intersection component does not occurs because X makes only new friend, only one new friend. So the intersection probability would be 0. So that's why you get only the sum PA plus PB plus PD. So if it made more than one new friend, then that intersection sum would have come. So basically, let me write what you are saying. So P A union B union D would be P A plus P B plus P D, and then you have the various union components to it. So I think it is minus of P A intersection B minus P A intersection D and minus P A intersection B intersection D, and
Yeah.
finally A intersection B intersection D. So these terms, so all these terms are 0 here, 0
Yeah.
for this problem because X makes only one friend.
Yeah.
That's why only PA plus PB plus PD would give you 8 out of 30.
Yes. Yes. Yes, sir.
Yeah.
That's okay, sir. Fine.
Okay. Yeah. Yeah. Anyone has any other question?
It means if there is a only one or new friends, we have to use a Barabasi model, sir.
Yeah. So so if it makes, let's say, two friends, then you use the assumption that it makes two friends independently, and then you multiply the probability and you get it. So there is a problem in, like, I'll discuss one such problem in the upcoming slides. So there it makes more than one friend, and so, and we assume the friends are formed independently, and we find the probability by multiplying. So in
Any
such problems,
specific condition, sir? Any specific condition for a Barabasi-Albert model?
so this Barabasi-Albert model is usually used in preferential attachment network where making such new friends. So
Yeah.
in this course, if they specify that a new friend is getting added to a graph, so it is assumed that it follows such type of model, Barabasi-Albert model. So there a new, let's say X is a new node, and so if you did not follow the Albert Barabasi model, it could have formed an edge like at random. So the probability of getting attached to A, B, and D would have been equal. But in such cases, because when we form friends, it follows the type of principle, the rich gets richer. So we make friends with people who already have a lot of friends. So under such assumptions, we use this Barabasi-Albert model. So
Oh,
either this would be mentioned, or if a network where it is given that a new node is forming a friendship, so then you assume that they are following the Barabasi-Albert model.
okay, sir. Okay. Thank you, sir. Thank you.
Okay, all right. So moving on to the next question. In the above question, so I'll show you the graph once again. Assume X made friends with C, D, and E. So now X is attached to C, D, and E. Y is another new node which arrives at the next step. What is the probability that Y makes new friends? So now they are saying that X is connected to C, X is connected to D, and X is connected to E. So total edges, total degree, basically degree, would be twice the edges. So initially, there were 15 edges, and now due to X, 3 more edges have been formed. So total number of edges becomes 36 now. And the degree of D and E increases. So previously, the probability of attaching to C was 3 over 30. Now, so old degree, and this is node C, and new degree. Old degree was 3, new degree becomes 4. So what is the probability that Y makes friends with C? So basically it is this new degree by total degree. So 36. So 4 over 36. So option C is the correct answer. So this is the probability with which Y makes new friends, becomes friends with C. Okay, coming to the next question from the past example. Now Y, let's say, became friends with B, and X became friends with C, D, and E. Z is yet another new node. Z is not friends with anyone. According to the richer gets richer phenomenon, what is the probability that a new incoming student W makes friends with Z? So what is that? That you had this existing graph. So let's say this is a simplified version of the graph maybe. So this is the graph G, and it contains uh, all the nodes A, A, B, C, D, E, F, and here is Z. Z has no friends. So by the Albert-Barabasi model, a new student W will the probability of attaching itself to any node in G, probability of attaching to any node in G is non-zero, because if you see, the graph is connected. So the network is connected. So every node has at least one edge going out. So every node has at least one friend. So the probability of attaching itself to any of the nodes in this graph G is non-zero. But probability of attaching to C will be zero, because Z has no friends. So the right answer would be 0 over 38. So why 38? Because we added we added one more edge. Y became friends with B. So, and total degree is twice the number of edges. So you add one edge, so total degree increases by 2. So it became 38. That's why the denominator is 38. But that doesn't changes the answer, because the numerator is the total, the number of degree of this node Z, which is 0. So node Z has, so a new node W attaches itself to node Z with 0 probability. So the right answer is 0 over 38. Coming to question number 8. In the given graph, with whom should a new node Q make friends so that another new node X has an equal probability of making friends with each node present? So if you let us look at this statement, new node X has equal probability of making friends with each node present. It is given that X joins after Q has made friends. So first Q attaches to some nodes, and then X comes. So Q attaches to such friends where the such that when X comes, probability of attaching to all nodes are equal. So let us see how first let us look at the degree of each of the nodes in this graph. So D has 3 degree, H has 3, L has 2, F has 3, B has 2, E has 3, C has 2, O has 3, W has 3, A has 3, T has 3, G has 3, P has 3. Now you bring in this new node X. Sorry, you bring in this new node Q. Now, if you look at these nodes, node L, B, and C. Now, if Q attaches itself to L, to B, and let's say to C, then it will become degree of Q would become 3, degree of L will become 3, degree of B will become 3, and degree of C will become 3. And all other nodes in the graph will also have a degree of 3. So basically, Q must attach itself to these 3 nodes, B, C, and L. So the right answer is option C, B, C, and L. All right, let us move on to the next question. Okay, so in a given graph, each node represents a student and each edge represents a friendship. A new students join, a new student X joins and makes 2 new friendships. With what probability does everyone have 2 friendships? So again, let us look at this. With what probability everyone has 2 friendships? So so you have this node X that is introduced, and existing degree is 1, 2, 2, 2, 2, 2, 2, 2, and 1. So now it is saying that now X can attach itself to any of these nodes in the existing graph. It has to attach to 2, but when what is the probability with which everyone has 2 friends? When does everyone have 2 friendships? When X attaches itself to D and A. In this case, X will have 2 friendships. Degree of X will become 2, and degree of D will become 2, and degree of A will become 2. So what is the probability? Basically, the question is uh, probability of X attaching to D and A. So in such a case, we assume independence. So X attaches itself independently to D, and X attaches itself independently to A. So uh, attaching itself to D does not affect its decision to attach itself to A. So in such a case, so probability of attaching to D and into by independence, we get the product of the two probability of attaching to A. So probability of attaching to D. So if you look at the blue colored degrees, so there are total how many edges? 1, 2, 3, 4, 5, 6, 7, 8. So 16. So and degree of D is 1. So total number of degree would be 2 into 8, that is 16. 2 into 6. And probability of attaching it to A has also degree of 1, 1 over 16. So the right answer is 1 over 16 into 1 over 16. So option B is the right answer. Okay, let us move on to the final question. So in this given graph, so probability distribution for new nodes to make friends with each node, which of the following is correct? So you have this given probability and you have three sets of graphs, and they're asking that which graph actually correctly corresponds to this probability distribution. So again, the probability distribution is basically proportional. Okay, let me write it. Probability distribution, probability of attaching, of making new friend is directly proportional to degree of node. So what we have to check is basically the degree. Check degree of nodes in the graphs, and that would give us the probability. So basically the ratio, if you see, so what this statement means, let's say P of A is to P of F is to P of W is to, and so on, to P of D. This is the probability of attaching it to its node. The ratio would be equal to the proportion is the same as the degree of A, degree of F, degree of W, and degree of D. So basically we will check the degrees in each graph. So let us count let us look at the degrees. So coming to case 1, degree of A is 2, degree of F is 4, degree of W is 5, degree of H is 3, degree of T is 6, degree of B is 4, degree of P is 6, degree of Z is 4, degree of D is 4. Now let us correspond it to the table. So P of A is to P of B F. So the ratio is basically uh, so the ratio is basically 2 2 is to 4 is to 5 is to 3 is to 6 is to 4 is to 6 is to 4 is to 4. So in this proportion, the degree must also be distributed. Now let us check whether it is correct or not. All right. So for node A, it is 2, correct. For node F, it is 4, correct. W 5, H 3, T 6, B 4, P 6, Z 4, and D 4. So case 1 satisfy is a correct graph. So case 1 is correct. Let us repeat the procedure for case 2. A is 2, uh, F is 4, W is 4, H is 3, H is 3, T is 6, B is 4, uh, P is 6, Z is 4, and D is 4. Again, you can see that Here also it is in the same proportion. A is 4, F is A is 2, F is 4, W is W is sorry, my mistake here. W is 5. So W is 5, but it is in the same proportion as earlier. So W is correct, 5. Then H is 3, which is correct. T is 6, correct. B is 4, correct. P is 6, correct. And Z is 4, correct. So this graph is also correct for the given probability. Coming to the final graph, let us again calculate the degrees. For A, node A, it is 2. For node F, it is 4. For node W, it is 5. For H, it is 3. For T, it is 6. For D, it is T. For B, it is 4. For P, it is 6. For uh, D, it is 4. And for Z, it is 4. And let us again check these. So if you check with the previous itself, so A was 2, correct. F 4, correct. W5, W5, correct. W5, then we have T6, correct. D4, correct. Z4, Z, yeah, Z is 4. This is also correct. H3, correct. P6, P6, correct. B4 is also correct. So this option is also correct. So the right answer for this question would be all three. So 1, 2, and 3, all of them are correct. So that was all that we discussed so far. So if you have any questions, you can, yeah, go ahead. Uh, if you have any questions, you can speak up or you can type in the chat box as well.
ನಾವಲ್ವಾ ಯಾವ
And so someone has asked a question that given a set E 1, 2, 3 up to 15, we pick A1 uniformly at random from this set. Next, we pick another A2 again uniformly random, and we let's say we pick 13 more. So we have this A1 to A15, a total of 15 numbers that pick, and we look at the sum. Which of the following sets define the range from which the sum S can have the value from? So the lowest value that S will have is if all of them, all these A1, A2 are 1. So lowest value would be 15, and the highest value would be 15 into 15, that is 225. So the range would be from 15 uh, to 225. So the first option would be the correct answer. So 15, 16 to 225. Okay, so that is clear. So someone is asking for question number 1. So the question number 1 says that in a random graph with 500 nodes and edges between any two nodes with probability 0.27, where can one expect the peak of the degree distribution? So the degree distribution basically, so this type of a graph in a random graph where edges are added with a given probability, fixed probability. So this follows the Erdos-Renyi model. So in such a case, the peak of the distribution occurs at P is the given probability P into max degree minus mean degree. So this is where the the max degree is 499 because each node can attach itself to uh, 499 other nodes, and minimum degree is 0, that it has no it is not connected to any of the nodes. So 0.27 into so 499 can be approximated to 500, so it would be around 135. So around 135 we can expect the peak of this degree distribution.
Excuse me, sir.
Yes, go ahead.
Yeah, in assignment number 9, question number 6. In question number 6, there were two options are correct. Were correct.
Which question? This question or
No, 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 no. In assignment number 9.
so this year's assignment number 9 you are saying?
Yeah. Which we have been already submitted.
Okay,
Uh, Node C and B have the highest degree. It means equal degree, 4 degrees.
okay.
Yeah, question is given a network being generated by the rich get richer phenomena shows the snapshot of the network at time t. A new node U enters the network at time t plus 1 and make an as with one of the existing node. What is the node that has high probability to form an as with the new node U? Uh, Node A has the 3 degree, node B 4 degree, node C 4 degree, node E 2 degree, node D 3 degree. And answer
Uh,
are A, B, C, D, A, B, C, D, E. Then
uh,
what will be the probability of a to form a new friend? High probability of the nodes.
do you have the screenshot? Can you attach it in the text box so everyone can see?
I can share, sir.
Okay.
Yeah, just a minute. Is it visible, sir?
Uh, yes,
This one?
I can see the
This.
network.
Yeah. This one, sir. This one. Question number 6.
Okay, so mm,
Is it visible to you?
yeah, I can see it. Like I cannot see your screen, but I can see it in the chat window. So maybe you are trying to share your screen.
Just a minute, sir.
Yeah. Okay. Okay. Yeah. Now I can see it. So okay.
I am sharing in chat box, sir.
Yeah. Yeah. Okay, so here your question is that both B and C have equal degrees. No.
I have a posted it in chat box, sir. You can see.
Yeah, yeah, I can see it.
Yeah,
Mm.
yeah. Please see.
Yeah. So given the network, a new node U enters at the time t plus 1 and makes edge with one of the existing nodes. So at time t plus 1, and what is the node that has the highest probability to form an edge with the new node uh, U. So okay, so in such a question, so B and C are both correct, it seems, but in the option that they have given only C as the correct answer, right?
Yeah. According to power law, both
Mm.
option must be correct, sir.
Yeah, yeah, you are right. Both of them should be correct. So
And
the reason,
we have already raised the query also
okay.
in a discussion form, but they have not changed yet now, sir. And
Oh, okay, okay.
in previous assignment also, there were also some problem in matrix model, Markov matrix model answer.
Yeah.
Uh, they have not changed the grading point till now.
Oh, but they had replied to you, right? That they will change.
But they have assured also to us
Okay,
by email. Yeah, we have got a email message also
okay,
from discussion forum, but not changed till now.
okay, okay.
Yeah,
Yeah, what you say is right that both B and C can be both can be correct options here. If-
yeah. Yeah. B and C must be both correct answer for this question.
Yeah, yeah,
It means if we are putting B or C, or both option must be there.
yeah, both option must have been there, I think.
Yeah,
Yeah,
yeah. That will be the correct answer.
yes.
But they have not changed the grading point, sir.
I think
We
they will reply to you. Like I think they have not checked it, but since this is what you say is correct that both, so they will like uh, in few days time they will get back to you, and then you can write to them once again that it is if for the previous week that you're saying that they said that they will update but haven't yet updated, so maybe there is some delay in the administrative process, but otherwise what you say is correct. I agree with
yeah,
you.
they should correct it, sir.
Yeah, yeah,
In
yeah,
coming days,
yeah, yeah.
we have already have been raised these queries for correction.
Okay, okay, okay.
Yeah, yeah. Okay. Thank you, sir.
Yeah. So anyone has any other question? Okay. So if you do not have any questions, so you can start leaving. Tomorrow, week 10's questions will be discussed in the same time slot by a different TA. All right. So thank you for taking the time to join the TA session. We'll meet again next week and all the best for your course. So